Hello everyone, welcome to today's class. This is Teacher Simon taking you through Pure Mathematics 3. This is paper 9709/33 for May, June 2025, and this is part 1 for questions 1 to 6. Question 1 is coming from modulus functions. They are saying part A, we sketch the graph of y is equal to the modulus of 3x minus 2a, where a is a positive constant. Now when I'm sketching this one, I'll first consider the equation of a straight line, which is y is equal to 3x minus what? 2a. And then I just find two coordinates, especially where the graph meets x and y axis, okay? So on x axis, we know that y is 0. On y axis, we know that x is 0. So if x is 0, put a 0 here, you'll get negative 2a, right? And then when you put a 0 here, on y, that means this one will come this side, then we shall have 2a, and then we shall divide all through by 3, not so? So we shall have 2 over 3 of a. Now we shall draw our graph here, and these are going to be the axes. I'm going to put them in terms of a, since you can see that I'm having an a here, I'm having an a here. So a is going to be amongst what I'm going to have on the axes, okay? Okay, now let's vote. We have 0, 2a. 0, negative 2a is here. Okay, then we also have 2 over 3. 2 over 3 is 0.6 recurring. So 0.6 is after maybe 0.5 there. So we shall put it, let's say, there. And then we draw. So we can connect this to that, just like that. But again, this part here, which goes beyond the x-axis, we dot it, or we even rub it off completely, because we are supposed to reflect it in what? In the x-axis, because we are dealing with the modulus, the positive. So what is negative? The negative y value now turns out to be the positive, okay? I can even label this like this: y is equal to 3x minus 2a. This part here was already positive. It was already above what? The x-axis. But again, this one is the reflected one, so I can put minus of it, 3x minus 2a, okay? So that is our sketch there. And then part B, hence or otherwise, solve the inequality, this one here. Hence, that means we can begin from where we have stopped. In other words, we can do the sketching, or otherwise, I can use any other method. Now let me use the hence part. So I need this line here to be drawn on the same graph. Okay, so if I have y, which is equal to x plus 5a, I'll need also two coordinates like I've done for the other one, to know where this one is cutting x and y axis. So we have x and then y. When x is 0, this one will be 5a. And then when y is 0, that means this one will be negative 5a. So negative 5a 0 is here. And then the other one is going to be 0, 5a. 0, 5a is up here. Now we can draw a line and then through those points. So this one actually goes beyond. This one goes beyond the x-axis because it is not having the modulus, okay? So if I can just do that, we draw and then make it do what? Like pass through the x-axis, okay? So this is y, which is equal to x plus what? 5a. Now this line we have drawn intersects with this reflected part here, okay? But on the look of things, it looks like it also intersects with this positive part of the graph, the original positive graph, okay? So we have to look at those two. Now, when you do sketching, you can get to know exactly where or this line you have drawn, which part of the modulus graph, the modulus function, it is meeting. Okay, you can draw and then you find that it is only meeting with one part. That means that is the one you're going to single out and then you solve. But this one, on the look of things, intersects the two. Okay, now there is the negative part, okay, which is we are having the negative part, which is 3x minus 2a negative. Okay, that is the negative of it, and then now less than x plus 5a. You see that? Then when we divide all through by the negative, remember we are supposed to make x the subject of the formula. The sign changes here, right? So we shall have something like that. So in the schemes, actually, you can find this one here. Okay, they usually don't write this first step here. So it is the modulus function that is having the negative and then the positive part. Okay, so in order to avoid making mistakes, always put the negative on the modulus function, and then later you can divide through to see this one coming. Okay, all right. Now, what are we having here? We solve this equation here, not so? Okay, so this will be 3x minus 2a, then greater than negative x minus 5a. So if I put x on one side, this will be 4x, then greater than, take this on this side, minus 5 plus 2, that one gives us a positive, a negative 3a. So that means our x here is going to be greater than negative 3 out of 4 of a. As simple as that. That is 1. Even when you look here, by the way, so that means where they meet. Okay, negative 4 out of 3, that is 1 point. Okay, it is 1 point. Well, this one doesn't look like perfect, but it is negative 1.3 recurring. Now, where these two meet, we can look at the right side and the left side. So when you look at the right side, this line here, okay, is above this one here. In other words, this modulus, the part of the modulus, it is below this one here. And based on the inequality here, they are saying this one has to be below, because this is less than, it has to be below this line. So it is therefore correct. When you go to the right, we can see this modulus, it is less than what? This graph here. This one is always above. As simple as that. Okay, now we can go back to this other one here. How about when we get 3x minus 2a, the positive part, okay, then intersecting with this graph here. So now we are looking at this other part wherever they will meet. Okay, okay, now we continue, bring this on this side, it will become a 2x, and then less than, when you take this one here, it becomes a 7, right? 7a, and then x is less than 7 over 2 of a, like that. So suppose they go and let's say they meet, that is 3.5. They meet here, 3.5. So this one now proceeds like that, this one goes like that, and this one has to be below. So if this one has to be below, then it will be on the left, because if it is on the right, then this modulus here will be above this one. You get it? So that's why we are taking the less than part. You get it? So here on the sketch, the moment you know the parts that are intersecting, and then you put them here and then you solve, you don't need to test. What comes out is actually the answer. Now suppose I use another approach. Alternatively, okay, the otherwise is going to be what? I'm going to I have always told people that if you see the modular signs on one side of the equation. Okay, if you see the modular signs on one side of the equation, you split. You consider the positive part of the modulus and also the negative part of the modulus. Are we there? Then you solve accordingly. So what we have done here right from the sketch is the same thing. You're considering the positive here, you're considering the negative here. So you're going to get the same thing. You see that? And then I've always also recommended that if you see the modular signs on both sides of the equation, you have them here, you also have them here, then you can square both sides. Okay? That is what you do. For that one, never split. Okay? Because there are like four cases to consider. But now here, even if the modular signs are on one side of the equation, you can still do what? You can still square both sides. By the way, I can even merge these two. X is greater than negative 3 over 4 of A, but it is less than 7 out of A. So merging these two, I'm going to get negative 3 out of 4 of A less than X, then less than 7 out of 2 of A. Then this becomes my final answer. You get that? So the two inequalities merged together, we get this one here. So suppose we square both sides here, we shall get 3x minus 2a squared less than then x plus 5a squared. So bring everything this way, you'll get 3x minus 2m squared less than minus then x plus 5a squared, which is less than 0. Here you don't need to waste your time. You open brackets, and then after that, of course, you are going to simplify. You are going to come up with a quadratic expression, and then you have to factorize it and then continue. But this is a difference of two squares, and we know that a squared minus b squared is equal to a plus b, right? Then into a minus what? A minus b. So my a is this one here, and my b is this one here. So I will first add them. I will add the x plus 5a. Then after, I subtract them. So minus, of course, the minus is going to affect both of them. Just like that. Then less than 0. Then we simplify. The 3 plus 1, that one becomes a 4. And then this one will be plus 3a. And then this will be 2a. Then minus 7. It's not 2a, it is 3x, then minus 7a, less than 0. So when I equate this one to 0, I'm getting negative 3a out of 4, okay, which is actually here. And then this one here gives us 7a out of 2, which is also what? Here. But we don't write these ones as the answers. These are critical values. I have to look at the regions, the region below or on the left of the smaller value, then in between, and then above. You see? Then above this big one, we need to look at the coefficient of x squared here. This 4 times 2x, it will give us 8x squared, not so? So this means that the coefficient of x squared is a positive. And since the coefficient of x squared is a positive, then we shall have a U-shaped curve. You see that? So when we have that U-shaped curve, then what we have gotten here as the values of x, those are the so-called boundary points or the critical points. So we shall have negative 3a out of 4, and then we have 7a over 2. This part that is above the x-axis is always positive, and then the part that is below x-axis is always negative. All right. Now, we are looking for the negative part, that is the less than 0. So this is what we are going to take here. You see that? So for that case, therefore, we conclude and say that our answer is actually this one here. As simple as that. Just like the way we wrote our answer up here is the one that we are going to have here. You get it? Question 2 is coming from logarithms. Solve the equation 2 natural log of 2x plus 3 minus natural log of 2x plus 5 then which is equal to natural log of 3x. Now we know that log of a b power c is equal to c log of a b. So I will need to put this one here. That means we are going to have natural log of 2x plus 3 squared, then minus the natural log of 2x plus 5, which is equal to natural log of what? 3x. When they set for you a number in logarithms, they are only testing for the rules. Do you know how to apply them? That is all. If I have log of a b, then plus log, which is minus log of c base a, then here, since the base is the same as subtraction, what do we do to the powers? We divide them, not so? Then this is going to be the same thing, 2x plus 3 squared, then we shall divide by the 2x plus 5, you see? And then this one is going to be equal to the natural log of 3x. Now, this is a natural log, this is a natural log of something. So since the two logs are equated, then that means that the powers are also equal, okay? So this simply implies that the 2x plus 3 bracket squared out of the 2x plus 5 then will be equal to 3x, okay? Then we can open the brackets and then simplify. So 2 squared here will give us 4x squared, then 2 times 2 times 3, isn't that 12? That is 12x, then square the 3, that is a 9. Then this side, 3 times the 2, that will be 6x squared, and then 3 times 5, that is a 15, right? That is a 15 x. Then we can take everything on one side to form a quadratic. 6 minus 4, you will get a 2, x squared. Then 15 minus 12x, that one will give us a positive 3x. And then when 9 crosses, it is also minus here, which is equal to 0. So this is a quadratic we have gotten. We can solve this one using a calculator very fast, and we go. You press mod, then you go to equation, which is 5, and then 3, that is quadratic. Then we can press 2, then 3, then negative 9. So this one gives us 3 over 2, and then negative 3. So 3 over 2, and then negative 3. You leave some space, but why I'm doing that, we need an attempt to solve the quadratic equation, which is given a mark. You don't reach here, you just write the answers and you go, okay? That is wrong. Okay, so give us the factors from which these roots come. So I can solve backwards. You can cross multiply, then you get 2x, and then bring the 3 this way. It will become a minus. You see that? Then bring this on this side. The factor then becomes x plus 3, which is equal to 0. So there you have cheated the examiner straight away. All right, now after that, you know that logarithms, we don't have logarithms of negative numbers, okay? Because there is no number, you are going to power with any number, and then you get a negative, okay? So we shall take the positive value here. X is therefore equal to 3 over 2. When you put this negative in here, you're going to have natural log of negative 9. You see that? If we say natural log of negative 9, the calculator will tell you what? It will tell you math error. You see that? So we don't have logarithms of negative numbers. Question 3 is coming from integration. Find the exact value of this integral here. Now we can see that this is an even power of cosine. And you need to know that for even powers of sine of an angle and cosine, for even powers of, in fact, let me just say, for even powers of sine and cosine, we use the double angle we use the double angle identities for cosine. Okay, this is cos squared. We have cos of 2x is equal to 2 cos squared x. This one is actually provided in the list of family if you don't remember. But then if we make this one the subject of the formula, we will bring this one here and then you divide all through by 2 not so. So cos squared x then is going to be equal to 1 then plus cos of 2x, then you divide by what? By 2. Now, having known that this one is that, we can actually check and see that this one is x here, but here we are having 2x. Okay, so meaning if we have cos squared of 5x, what we are given here, then we shall double it this side and we shall have cos of 5x, I mean 10x. Okay, when you double it, 10x out of what? 2. So this therefore implies that when we are integrating from pi over 5 to pi over 4, 3, then the cos squared 5 of x with respect to x, this one will be, I will put the 3 out here, and then pi over 5, then we have pi over 4. Then where there is this one here, I'm going to replace it with this. So I'll have here 1 plus cos of 10x. You see that? Now, instead, okay, I will divide this one by 2 here. You see that? Now, I can actually take out this half, the 1 over 2 that is here, I take it out. That means I'm going to have 3 over 2, because the half will come out here and multiply with the 3. So we have 3 over 2 here. And then when we integrate 1 with respect to x, we shall get an x, not so. When you begin the process of integration, you take away the integral sign and then you create these brackets. So we shall have the x there, then plus, when you integrate a cosine, you get a positive sign. Okay, then after that, you divide by the derivative of the angle there, which is 10. And then we can put these limits, pi over 4 and then pi over 5. So what do we then have? 3 over 2. Then inside here, you'll have now pi over 4 plus sine of 10 times pi, then over 4. And we shall divide it by 10 here. Then minus, now we put pi over 5 wherever there is x. So plus sine 10 pi out of 5, then over 10. Okay, and that is that. Then the rest, it is just simplification. Okay, so what do we get here? I have pi over 4, then plus, what do we have here? Your calculator has to be in radians, okay, if you have to use pi over 4. So we have sine, then 10 pi out of 4, and that one gives us a 1. So we shall have 1 over 10. Then minus, of course, this one will be a negative, and also this one a negative. Now this one will be 2 pi, not so? And sine of 2 pi is a 0. So plus 0 here. Now we can simplify our answer here. We can get pi over 4 minus pi over 5, pi out of 4, then minus pi out of 5. So we get pi over 20. So 3 over 2. Then we have pi over 20, and then plus 1 over 10. Okay, then from there, Of course, when we multiply by what is outside here, we shall get 3 pi over 40, then plus 3 out of what? 20. So that is the exactive value. They said we find the exactive value. You see this? So we are not supposed to put it in decimals. That is what we get. As simple as that. Question 4 is coming from complex numbers. Part 8 is given that z1 is equal to r1 e to the power of I theta 1 and z2 is equal to r2 e to the power of I theta 2. So this one is given in the exponential form. Show that the conjugate of z1 times z2 is equal to the conjugate of z1 times the conjugate of z2. Okay, now if I have, let's say, z, which is equal to, in the Cartesian form, x plus iy, then the z star, or the conjugate of z, it is going to be x minus I y. So we just change the sign of the imaginary part. All right, now here my z1, I need to find z1 times z2. So z1, right from here, it is given as r1, then e power I theta 1. Then we multiply by z2, which is r2 e to the power of I theta 2. Now this one will be r1 times r2, and then e to the power of, because this is multiplication and these are indices, we shall add the powers. So we shall have theta 1, then plus theta 2, then I. Okay? And from here, that means the z1, z2, the conjugate of this one here, it is going to be r1 times r2, then e to the power of, you just negate the what? The imaginary part. So we shall put a negative here, and then we put theta 1 plus theta 2, then I. Okay, as simple as that. Then we also go to this one here. Z, the conjugate of z1, it is going to be r1, then e to the power of negative theta 1i. Okay, and then the conjugate of z2, it is going to be r2, then e to the power of negative theta 2i. And then we are supposed to look for z1, the conjugate of z1 times the conjugate of z2. That means we are going to have this one here. Okay, then we multiply it with this one here. Not so? So we multiply them just like that. And of course, what comes out of here is going to be r1 times r2, and then e to the power of, this is negative theta 1, okay, then plus theta 2. This one is even a minus. So plus negative theta 2 of what? I. And then this one will become r1, r2, e to the power of, take the negative outside, then it will become theta 1 plus theta 2 of I. You see? So that is what they have told us to prove. Now, when you look at what we have gotten here, then this simply implies, when you look at this and this, they are the same, right? So therefore, z1, z2, then their modulus is equal to the modulus of z1 times the modulus of z2. As simple as that. Then part B, they are saying here that z is equal to this, is the root of this quadratic equation, where b and c are real. And then they are saying state the other root and hence find the values of b and c. The other root is always the conjugate of it, okay? Because when we are using minus b plus or minus to the root of b squared minus 4ac, okay, and you get a complex root, they always move in pairs because of this plus or minus. You get it? But of course, the other one, there is over 2a. So the other root The other root is the conjugate. Of z, which is equal to what? 3e to the power of to the power of pi out of 4i, which is, you can say z, which is equal to 3e to the power of negative pi over 4 of I. So this is the other root, the conjugate. Okay, now these two, if you're having two roots, let's say x is equal to a and then x is equal to b, these ones come from the factors x minus a, just like I've always been showing you how to solve the quadratic using a calculator. And then we can open this one up. So when we open, we shall have x squared, then plus, you'll have minus bx, then minus ax, then plus ab, which is equal to 0. So you see that you have x squared, then minus x is common, so I have a plus b, minus x, I put it outside. Now, do you see that here you are having sum of roots? Okay, sum of roots, and then here you are having product of what? Roots. So I will get this, okay, I add it to this one, I put it here, and then I multiply them, I also put them there. You see that? So this implies that we are going to have, or you can move systematically, and you say if z is equal to 3e power pi over 4i, and also z is equal to 3e power negative pi over 4i, then you have z minus 3e power pi over 4i, and then the other one is z minus 3e power negative pi over 4 of what? Of I, which is equal to what? To 0. Now we open the brackets, we have z squared, then z times this one here, you get minus 3e power negative pi over 4i of z, and then here, that will be minus 3, then e, okay, then pi over 4i, and then plus, because this is a negative times a negative, okay? So 3 times 3, that will be a 9, then e power pi over 4i times e power negative pi over 4i. We are going to add these powers, then these ones will cancel out, not so? And then we get a what? E power 0. So that means we are going to have z squared here, then minus 3z is common, and then we are going to have e power negative pi over 4 of I, and then plus e power pi over 4 of I, not so? Then plus the 9 here, which is going to be equal to 0. Now, compare this one with the z squared minus bz, then plus c, which is equal to 0. This implies that our c is a 9, then our b is the whole of this, and then the a is there, okay? So this implies that our c is equal to 9. Simple as that. And then minus b, I can say b is going to be equal to, and by the way, this one is a plus, is going to be equal to, this is the coefficient of z here. So we are going to have 3, which is a minus, then e to the power of negative pi over 4 of I, and then plus e to the power of pi over 4 of I. Now, we know that, if I can say NB, e to the power of I theta, this exponential, in the polar form, it is going to be cosine of theta, then plus I sine of what? Theta. So if I, let's say, put it here, what are we going to have? This b is going to be negative 3 into, we have cosine of negative pi over 4. You see that? Then plus I sine of negative pi over 4. Then plus, this one is positive, so I'll just shift whatever is here. Then I put it there. You see? And then I remove the what? The negative. So I will remove that and also remove that. Then after this one here, we get now the answers. What do we have? This is negative 3. Cos of a negative is the same as cos of a positive. So cos of pi over 4 is root 2 over 2. Then cos of the sine of the negative is negative sine of the positive. So here we shall get a minus, then root 2 over 2i. And cos of this one is, of course, root 2 over 2. And then this one is positive. So we have root 2 over 2 of I. Now, do you see that the imaginary part here is cancelling? And then from there, a half plus a half, you get a whole. Not so? So this means that b is going to be equal to negative 3 root of 2. As simple as that. Question 5 is coming from differentiation. They are saying the curve, the equation of the curve is this one here. Show that dy dx is this. Okay. Now here we are supposed to differentiate. This is a product of two functions. Y here is not expressed in terms of x. So this is an implicit function. Okay. So for an implicit function, first of all here, we are supposed to differentiate. It's a product. So we are going to use product rule. You keep x constant. Then you differentiate this y with respect to x. Then now we add, then keep y constant, then differentiate what? X. You see that? Then also come to this one here. I'm going to keep y squared constant. Then I differentiate e to the power of negative x. Then plus keep e to the power of negative x. And now you differentiate with respect to x. This y squared. And then this way you also differentiate this constant with respect to x. Now here we are using product what? Rule. But again, actually let me add it there. We can put it here. And I say using the product rule. The product rule, that's what we shall have. Now we see derivative of an exponential function. We know that when you differentiate with respect to x an exponential function, okay, you look at the power of this e, then you differentiate it. So it will be f prime of x here. Then after you multiply it all through that exponential function, okay. And then also when we differentiate with respect to x, a function in y, okay? Y is a function. So we are having two variables here, x and y, but we are differentiating that function of y with respect to x. So the first thing we shall do, we shall differentiate that function with respect to y. You see that? Then after that, we shall multiply it with dy dx. So here we are using chain rule. So this one can cancel with this such that you have the derivative of this function with respect to what? To x. You see that? So that is what we are going to do here. When you differentiate y with respect to y, you get a 1. A 1. But then you will multiply by dy what? Dx. Then plus, when you differentiate of course x with respect to x, you will get a 1. So we shall have 1. Okay? Y here, then times 1. And then here, we shall have y squared times, you get this power, and then you differentiate it, you get a negative 1. Then you will multiply by this function here, okay? That I'm applying this one here. Then next, we shall have e to the power of negative x, then times, when you differentiate y squared, with respect to y, you'll get 2y, not so? But then we shall multiply by dy dx, applying our chain rule here. Then, of course, when you differentiate a constant, you get a 0. Now, let us look at those terms that have gotten dy dx. We put them together. So we shall have an x here, and then there is a 2y e to the power of negative x. So I factorize out the dy dx. Then I can take these ones, this other side, okay? So this one, which is negative, when it crosses, it becomes a positive, right? So we shall have y squared e to the power of negative x. And then what else do we have? We have this one here. When it crosses, it becomes a minus. And then that implies that our dy dx is going to be equal to y squared, then e power negative x. In fact, this one can be written as y squared, then out of e to the power of x, then minus y. Then we shall divide by x, then plus 2y, then out of e to the power of x. Now, looking at what we are having here, let me just simplify this fraction here, okay? So I'm going to do an operation on this one here, and the same operation should be done on this one here. So I can just say multiply by e to the power of x, as simple as that, okay? Multiply by e to the power of x. So what I've done here up is what I've done down here. That means the two can cancel, not so? So now our dy dx is therefore going to be equal to this one times this one here. It just disappears and you will remain with a y squared, okay? Then this one times this, you will have your y, then e to the power of x. And then this times this, you will get your x, then e power x. And then when this one multiplies with this, the e to the power of x disappears, and then we have a 2y. If you can observe clearly, it is exactly what they have told us to prove, not so? So that is that. Don't you see here? All right. Then part B, they're saying find the gradients of the tangents to the curve when x is equal to 0. So when x is equal to 0, what is y? Because when we are getting the gradient of a tangent, we substitute in y dx, and here we can see that there is a y coordinate. So we can substitute in the equation of this curve, which is xy. So we shall have 0, then plus y squared, and then e power 0, not so? Then is equal to what? To 4. So that means we have y squared, which is equal to 4. When you take the square root, then that means y is going to be equal to plus or minus 2. Okay. Now, we have this point 0 and positive 2. What is dy dx here? So dy dx here is going to be, this is 2 squared, then minus 2, then e power 0, out of, this will be 0, then plus 2 times 2. So here we have 4 minus 2, that is a 2. Then out of a 4. Then this one gives us what? A half. And then for x, then minus 2 here, what will be our dy dx? This one is going to be negative 2. You square it, then minus 2, minus, not so? So you have minus, then minus 2y. Remember, y here is there, but there is also minus here. Then e to the power of 0. Then we divide by 0, then plus 2 times a negative 2. So this one here turns out to be what? A plus. Okay, clearly we can see that this is 4, then plus 2 out of negative 4, 6 out of negative 4 by 2, 3, then by 2, 2. So these are our two answers here. These are the gradients when x is equal to what? To 0. Question 6 is again coming from complex numbers. Find the complex number z for which z plus 4 out of z plus 4i is real, and the modulus of z is equal to 10. Give your answers in the form z is equal to x plus iy, where x and y are real. So if they have said that this one is real, that means its imaginary part is 0. Okay, so z plus 4 out of z plus 4i, this one is going to be equal to, and this is x plus y, iy, not so? Then plus the 4, then out of x plus iy, then plus the 4i, which gives us, what do we get here? Let me separate the real from the imaginary. So then plus iy, then we divide by, this will be x, then plus, this will be y plus 4, and then I. Okay, now from here, we rationalize, or we realize the denominator. Sometimes people say realize or rationalize the what? Denominator. So what do we mean here? You get the conjugate of the denominator, you multiply it in the numerator and the denominator. So we have x plus 4, okay, x plus 4 plus iy. Then this one we shall multiply it with the conjugate of the denominator. You just change the sign of the imaginary part. So we shall have x then minus y plus 4 here of I, and then we divide by x plus y plus 4 of I. Then we also multiply by x minus y plus 4 of I, just like that. So it's like I've done nothing, because this one can easily cancel with that. You see that? All right. Now we should also know that I squared in complex numbers is always equal to negative 1. Now this is x plus 4 times x. We shall get x squared then plus 4x. Then again, this one here has to multiply with what is here. So we shall have a minus here, okay? Then this one is x plus 4 times y plus 4 what? I. Are we there? Then this one's multiplied, we shall get xy I. And then this one and this one here, you are going to have, first of all, I multiplying with I, it becomes I squared. And there is a minus here, so it will make it a positive. So I'll just write plus, then y into y plus what? Plus 4. Then we divide by, this is the difference of two squares, okay? A plus b, and then a minus b, not so. This is my a, this is my b. So I'll say x squared, then minus, my b is going to be y plus 4, okay, squared. But remember, there is also I squared. Do you see that? So this one will turn out to be a plus. So I don't put that I squared, then I will just put this one here. Now, after that, now separate the imaginary from the real. So I can have x squared plus 4x. Then this one here is y squared plus 4y. Okay? And then this one is going to be out of x squared plus y plus 4 squared. And then we have a plus. Now the imaginary part is going to be the whole of this. So we have xy, then minus, let's open the brackets here. We shall have minus x times y, that is xy, then x times 4, that is 4x, and then this is 4y. Now we are going to have a minus here, 4x, then 4y. Remember, there is a minus, so it affects everything, okay? And then 4 times 4, that's a 16, so minus 16. And then After that, we shall divide everything here by x squared plus y plus 4 squared. And right from here, I can have this one duplicated here. What are we seeing that is disappearing? It is this xy here. You see that? Xy disappears. That means this is my numerator here. You see? And then after that, remember I said if this one is real, then the imaginary part is what? Is 0. So for z plus 4 out of z plus 4i being real, okay, then the imaginary part is equal to 0. So where is the imaginary part? Isn't it this one here? Oh, by the way, I was supposed to put an I to this one. Okay, so pardon me here. I was supposed to do this, then put an I. So then I will get this one here. What is inside here? Okay, this whole thing. And then I will equate it to what? To 0. Then I can proceed. And from here, if we can cross multiply, we can see that we have negative 4x minus 4y, then minus 16, which is equal to 0. You get it? Then if I pull out the negative 4, then I will have x plus y plus 4, which is equal to 0. Then I can express y in terms of x or x in terms of y. You get it? So y here is going to be equal to negative x minus what? Minus 4. Okay, I keep this equation here. All right, then they also told us that the modulus of z is equal to, is it root of 10? Root of 10. So that is root of 10. That will be the square root of x squared plus y squared, which is that. And then these ones will cancel out. And then we have x squared, then plus y squared, which y is negative x minus 4 squared, which is equal to 10. Then we can open the brackets. When you square negative x, you get a positive x squared. Then 2 times negative x times negative 4, that one will give us a positive 8, right? And then square the 4, the negative 4, you get a positive 16. I can bring the 10 here, then it's equal to 0. Then the quadratic equation that comes out of this is 2x squared plus 8x plus 6 is equal to 0. Divide all through by 2. It is x squared plus 4x, then plus 3, which is equal to 0. The two numbers I can multiply to give me a 3, but when I add them, they give me a 4. That is exactly 1 and 3. So I'll put x plus 3 and then x plus 1, which is equal to 0. So when I equate this one to 0, then our x is going to be equal to negative 3. And also when I equate this one to 0, x becomes a negative 1. You see that? Now for each of these values, we need to get the y values. So we can say for x, which is equal to negative 3, then y is going to be negative of negative 3, then minus 4. This one becomes a plus, not so? Don't we get a negative 1? So therefore, one of the z values, it is going to be, what is the x? X is this one here, which is negative 3, not so? So we shall have negative 3, and then the y value is a negative 1. We shall have that negative 1i, but we just write negative what? I. And remember, z is x plus iy, right? So that is that. And then, how about when x is equal to negative 1? So for x, which is equal to negative 1, that means that our y is going to be negative of negative 1, then minus 4, not so? And then this one becomes a positive 1 minus 4. You get a negative 3. Okay, so this simply implies that our z is therefore going to be equal to the x coordinate is a negative 1, and then the y is a minus 3. So we have negative 1, then minus 3i. So those are the two z values that we are getting from here. As simple as that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.